Today we are talking about lesson 31, flowchart and paragraph proofs. We start with a warm-up to ignite previous learning. The first question for the warm-up is the vocabulary. The process of using logic to draw conclusions is called blank reasoning. So the two types of reasoning that we have are inductive reasoning and deductive reasoning. Inductive reasoning, you use information you have from previous knowledge to make an assumption outside of that knowledge. And deductive reasoning is you start with a set of laws and then you break that down into, you start off with everything and you break that down into smaller numbers. That's why it's in deductive reasoning. You're deducting from the total number of options. So using the process of logic to draw a conclusion. So because we're drawing a conclusion that is telling us further information beyond what we have, that means it is inductive reasoning. Our reasoning is already there. All right. Question number 2 is multiple choice. Which set of numbers are a Pythagorean triple? So we have two pieces of information. We have Pythagorean and triple. So Pythagorean triple is 3 whole numbers that when you put them into Pythagorean theorem, they end up giving you a true statement. Just as a reminder, the Pythagorean theorem is a squared plus b squared is equal to c squared. So using that information, we know the Pythagorean triple. So using that information, we know the answer is not b because that square root of 2 is not a whole number. 1, 2, 3, we can plug those numbers in. We have 1 squared plus 2 squared, and we're trying to see if that is equal to 3 squared. Well, 1 squared is just, so 1 squared is 1, plus 2 squared is 4, and we want to see if that is equal to 3 squared is 9. 1 plus 4 we know is not equal to 9, so this is not equal, so the answer is not A. Using C, all the 3 numbers are the same. So if we plug in 1 into both of these, C has to be a larger number. So because none of the numbers are larger, we do not know which one is C, so it cannot be that answer. Now we can check 3, 4, 5. We have 3 squared plus 4 squared is equal to 5 squared. We're testing that. Oops, we're testing that information. So we have 3 squared we should know as 9, plus 4 squared we should know as 16, and 5 squared we should know as 25. And adding those together, 9 plus 16 is in fact 25. So this is our answer. It is answer. Number 3 asks us to write a conclusion based on these statements. What law has been used to make this conclusion? When we're talking about conclusions, there are 2 types, or there are 2 laws that we can use: law of detachment and law of syllogism. So law of syllogism is where you have 2 conditional statements. If P then Q, if Q then R, and you use that information to give you if P then R. Let's see if we have 2 conditional statements here. If the milk has gone bad, and we can add the word then I will go to the store. The milk has gone bad. We do not have a second conditional statement. We do not have a second statement in the form of if then. So that means we cannot use the law of syllogism. So then we need to use the law of detachment. The law of detachment is if you have a conditional statement and a true statement, then you can a true statement that is the hypothesis, then you can say that the conclusion is going to happen. So here we have, if the milk has gone bad, I will go to the store. So the hypothesis is the milk has gone bad. The conclusion is I will go to the store. Now looking at our second statement, it says that the milk has gone bad. Well, that is just our hypothesis again. So that means we know that the answer is going to be therefore, I will go to the store. All right. So now we move on to our question of part 1. It asks us to write a 2-column proof from the given flowchart proof. Well, we've talked about 2-column proofs in the past, but now we have this flowchart proof. Well, we need to know what a flowchart proof is. So let's start talking about flowchart proofs. So a flowchart proof is a style of proof that uses boxes and arrows to show the structure of a proof. A flowchart proof should be read from left to right or from top to bottom. Each part of the proof appears in a box, while the justification for each step is written under the box. The arrows show the progression of the proof's steps. So here we are asking to interpret a flowchart proof. It says use the given flowchart proof to write a 2-column proof. Given that angle 1 and angle 3 are congruent, angle 1 and angle 2 are supplementary, prove that angle 2 and angle 3 are supplementary. So here it's asking us to do that thing. So we already have all of the logic, we already have all the steps, we already have all of the logic, we already have all of the justifications. So all we have to do is copy the things from the boxes into the left column, and everything that is outside of the boxes into our right column of a 2-column proof. So for this, we have that. We have angle 1 is congruent to angle 3. We know that is true because it is given. Angle 1 is supplementary. Supplementary with angle 2. The reason for that is it is given. So all we're doing is we're taking the information from the boxes and putting it in the left column. We're taking all of the words and putting them into the right column. Now we have measure of angle 1. Measure of angle 1 is equal to the measure of angle 3. Well, the reason we know that is because it's the definition of congruent angles. We already have the justifications written out for us. It is the definition of congruent angles. Definition of congruent angles. We also know that measure of angle 1 plus measure of angle 2 is 180. Measure of angle 1 plus measure of angle 2 is equal to 180. And that is the definition of supplementary angles. So now we take the next step, measure of angle 3 plus measure of angle 2 is equal to 180. And that is a substitution property of equality. Then our last step is what we are trying to prove. So the last step is angle 2 and angle 3 and angle 2 are supplementary. Angle 3 is supplementary. Angle 2. And that is the definition of supplementary angles. So all we're doing is we're taking the information from the boxes and writing it into the left column, the right column with the elements. So here is that same thing, except small. So now using this, we want to write a 2-column proof with a given flowchart proof. So let's take these two, make them a little bit smaller. So that way we can, let's take this, make it a little bit smaller. That way we can use this to do our 2-column proof. So we're doing a 2-column proof. We take a big old T So we have angle 1 is complementary. To angle 2. We know that because it has been given. Now we can use that definition of complementary angles. So we know that measure of angle 1 plus the measure of angle 2 is equal to 90 degrees. All we're doing is we're following the arrows. Here we only had one arrow going in here, so we can just kind of put it next to each other because that just makes it a lot easier to read and say, oh, this is why. This is how we are using that information. And that is the definition of complementary angles. Definition of complementary angles. So now we go to the other side. We have measure of angle 1 is congruent to angle 3. We know that because it has been given to us. So now looking under that, we have measure of angle 1 is equal to the measure of angle 3. Measure of angle 1 is equal to the measure of angle 3. And we can say that because of the definition of congruent angles. Congruent angles. Now we use this piece of information and this piece of information, the two lower steps on that, to combine into measure of angle 3 plus measure of angle 2 is equal to 90 degrees. And what we used there was we substituted in measure of angle 3 for measure of angle 1. So that's the substitution part. Substitution property of equality. Now we have measure of angle 3 and angle 2 are complementary. So angle 3 is complementary to angle 2. And we know that because of the definition of complementary angles. And that is it for part 1. I will see you shortly for part 2.